Hello and welcome to the 7th video of my Pygame tutorial. If you remember last time, we basically said we're going to work on collision. So if you want to think about collision in the most difficult sense you can, let me draw you two boxes. So if you have one box like this, and then you draw another box like this, well, you can obviously tell that these two are colliding. And how do you do that? Well, you have to start looking at all of these, corners, seeing if this corner is, greater than this corner, and then make sure this is also valid. Basically, you have to check, does this box in here exist? And that's can be quite complicated depending on how you want to do it. Or we can have Pygame do it for us, because Pygame has a method of doing it that's much, much easier and probably more efficient, since I'm sure it's probably optimized for it. But it's much easier than having us do it ourselves. So let's take a look at how we're going to do this. And the first thing we need to do is convert everything to a sprite. Now, there's a very specific reason, and if you've ever done Pygame, you know this, that I've been calling this self.image and self.rect, and I've been creating this thing called update. There's a very specific reason I've been doing this, and that's because this is the exact format a Pygame sprite uses. So if we're going to create a Pygame sprite, then first off, we need Pygame initialized and everything, and then we need to basically extend our class from a sprite. So we do that is we cause our class to inherit the Pygame sprite, and then we get all of the different functions that are part of it. So all we have to do is say Pygame.sprite sprite with an uppercase S, and this is what we're inheriting. So we're going to inherit the Pygame sprite. And when we do this, we also have to call its constructor by saying Pygame.sprite.init self. And this is going to call our object into the Pygame constructor, and then basically we're going to be given access to all of the Pygame variables and functions that are in the sprite, as well as given, since this thing is now basically a sprite object from Pygame, we can use things like sprite groups from Pygame, which will speed up things quite a bit for us. Sprite groups do a lot that's very nice. For example, one thing that they do is collision detection. So what we've done here is we've made this a Pygame sprite. This is all you have to do to turn it into a sprite. We still need to do a little bit more because sprites have a method of drawing themselves and kind of calling themselves into the world. So we're going to switch this up to use the sprite instead. Now, sprites have their own draw function as well as their own update function, which means we're no longer going to draw this. That's pretty much the only thing we're going to do differently, is we're not going to draw this in the update function. So we'll get rid of that. Alright, so I actually changed my mind about that. Let's see, let's just go back and re-add that line. So I do want this thing to be drawing. It doesn't really matter since there's only ever going to be one player object in existence. So I'm just going to add one conditional to when this thing gets drawn. And that is going to be if self dot is alive, and if we are alive, then we're going to draw ourselves. That's the only condition, because I need a way to stop drawing this thing if it dies. And then I'm just going to set a hard coded thing, self dot is alive equals true. And of course this means it's always going to draw, but this allows us some opportunity to set is alive to false, in which case we'll be able to stop drawing the player for whatever reason. Maybe it gets invisibility or it dies. It doesn't matter what it is, but this just gives us the control to do that for later. So now that that is resolved, nothing should be different about it. So let's run the main, make sure it's still working. There we go. We can still shoot, we still run around, and the boxes can't actually hit us. We can probably crash it. There we go. I had figured it would do that. So because the objects don't collide with us and they don't disappear and die, if they actually hit the center of us, then they will crash the game because it's division by 0. And I actually want to do that one more time just to test something. When does he stop? When his center hits our bottom right corner is when he considers himself in the center of us. That's very awkward. I'll work on it later, see if I can fix it, see if I find the issue. I'm not going to focus on it just yet because it's confusing me as to why it's doing that. It's probably me just having math wrong, which isn't such an anomalous thing. So the program still runs. That's the main key of this, even though we turn this thing into a sprite. So let's start turning our other objects into sprites as well. So we have bullets, and bullets are also going to be a pygame.sprite.sprite. If I can spell it right. And of course we have to initialize it again, so pygame.sprite. I keep doing that double, sprite.init self. Okay, and I know we're going to do this again, so I'm going to take a copy of this for later, because I know we're going to do one more of these. So now that the bullet is a sprite, we have a few options to change up how the bullet is basically being drawn. So our bullets don't get drawn in their own update, which is kind of important. So the only thing that actually happens as the bullets update is this thing. Travel. So we're going to rename that update. This is going to be basically saying, so every tick you're alive in the game, you're just going to do this, which is going to be moving, which is exactly what a bullet does. So it just moves in one direction. It doesn't do random things. We're not going to have smart bullets. Now, if these were missiles and, maybe they redirected themselves to target the enemy, then we would have some more logic in here. But for these bullets, their update is very simple. So now that we have bullets as a pygame sprite, let's change up this thing. Self.bullets equals an empty list. It's not a list anymore. Let's call this something else. Let's call this a pygame.sprite.group. So now bullets is a pygame sprite group. So now instead of appending them to bullets when we create them, for example right here, self.bullets.append bullet, now what we're going to say is self.bullets.add bullet. Because pygame sprite groups use add instead of append to add this thing to it. So now the bullet is being added to the pygame sprite group. Okay, that doesn't change anything yet, except instead of saying for object in self.bullets, object.travel, gamewindow.blit object, we can say something different. We can say self.bullets.update and self.bullets.draw. And what this is going to do is this function right here calls the update of every single object in that bullet group. Now, the pygame sprite groups don't have to have the same sprite. They just need any sprite that they can take and they'll do it. So we could have bullets, we could have ammo, we could have the player all in one group, and then we can call, all sprites.update, and every single sprite will update on that tick. But for now, we're just keeping it group oriented. So now we're calling the update on all of them, and then when we say self.bullets.draw, we draw all of the pygame sprites by blitting their self.image. So when we call this right here, self.bullets.draw, we look at the bullet, we take its self.image, and this has to be named this for the sprite to work, and its self.rect as these names, and we draw the image to the rectangle, which is exactly what we've been doing, except now it does it on its own kind of wide scale. So now we have this one set up as a pygame sprite. There's another thing we're going to make as a pygame sprite. So pygame.sprite.sprite. And of course we need to initialize it. Nice and quick with a copy paste there. And this one is now its own sprite. So, the enemy. This one's a little bit different. So, we don't have a list. So, previously the player it's only one object, so it doesn't need its own list. The bullets had their own list of self.bullets. This was a Pygame sprite group, but the enemy does not. So we're actually going to create the enemy list over here in the main function, which is a little bit different and might be a little weird, but if we put it in the enemy, then each enemy has its own kind of list, and that's even stranger. But we're just going to say, enemies equals a pygame.sprite.group, capital G, that does matter. And then when we create our enemies here, we're just going to say enemies.add enemy1, enemies.add enemy2. And of course, this thing, I'm going to change its speed to be 2, just so that hopefully it moves now, because remember at 1 it wasn't moving. So now this group has both of these when we call all of our updates. So enemy1.update, enemy2.update. Now we can just say enemies.update, enemies.draw, and that will update and draw all of the enemies from the list, and we can get rid of the self draw in the update function. So now everything should be working again. Let's test it, see where we're at, and it crashed. What did I do? Type draw takes exactly 2 arguments, 1 given. For the generic player. Oh, that's right. Self.draw game window. Forgot about that one. When you say when you say Pygame sprite group .draw, you have to tell it where you're drawing it to. So for this example, it's the game window, but you can draw these to different surfaces. So let's see. I think we have the bullet. Is our ammo actually using bullet objects? Spawn ammo, self.ammo.append, a new bullet object. Yes. So here's a good example of that. So we can say add. So self.ammo.add bullet. Now self.ammo is not going to be an empty list either. It's going to be a pygame.sprite.group. And now we say add. And when we pop from it, I don't believe we say ammo.pop. It's always going to take the end result. I believe this one would take a random result. How would we get a random bullet from within that list? Alright, so I actually had to check the documentation real quick. How we would do this in the sprite manner is if it would deselect that for me so I could highlight. Bullet is going to equal bullets.get sprite, and we're just going to say at index 0 so that we don't get any index out of bound errors. Self.bullets.getSprite. I believe that is the correct thing. If I just check again, get_sprite, and then we give it an index. Yes, it is. Of course, the documentation being very useful. And this is how we do it with sprites. And then we said self.bullets.addBullet. That works. This no longer actually removes it, so now it's kind of copying it into 2 places. If we wanted to remove it, then I believe we would also have to say self.bullets.removeBullet, since now we have an ID of the object called bullet. We get the thing at position 0 in our list. It's called bullet, and then we know what the ID is, so we just remove it after we've gotten a copy of it. And I believe this should work. We don't run this one, we run main. And we're still getting crash. Takes exactly 3 arguments, 1 given. Something takes 3 arguments. Enemies.update. What does our enemy take for its update? Oh, a game window and a player. It doesn't need a game window anymore. It just needs a player. So, I keep forgetting to make sure we pass everything. And it's just going to take player. Now when you call the update, it automatically calls the update with, it forces the parameter pass. So it'll automatically pass the parameter through to all individual updates. So let's check this again. Maybe it'll work now. There we go. It's working again. And these things, yeah, they still don't have normalized. They seem to move slower when I'm moving, which is really interesting. They move faster when I'm still, but they move slower when I'm moving. That is interesting. Anyway, let's let them collide with me. Of course, they want to collide with me very strangely. I'm still not sure why, but anyway, we'll deal with it later. Integer division by 0. Okay, everything is a sprite now. So, how do we actually do the collision now that everything is a sprite? Well, let's see. I want to get rid of this comments and stuff. I don't need them anymore. So let's see. Updates. Give myself a little bit of space, I guess. So Pygame will give us a list of sprites in groups colliding with one another. So if we say pygame.sprite.sprite collide, then we give it some individual sprites, so single sprite, a group, and then does group die, basically. So what's the single sprite? Well, that's going to be our player. What's the group? I believe that's enemies. And do they die when they hit us? I'm actually going to say false. I don't want the enemies to die when they collide with us, because I actually want to be able to handle my own death. And the reason for that is handling my own death allows me to change scores. Maybe when they collide with me, maybe they're extra strong and they bump us away instead of instantly killing us, they just kind of knock us away. And then they're still alive and we're still alive, and we're like, okay, let's try and kill you before you do that again. So what we can say is player collisions equals. Now this can be any name you want, of course. This is storing something. And this pygame.sprite.sprite collide actually returns a list of all things that of all collisions between player and enemies. It returns all enemies that are colliding with player. So now that we know all the enemy objects that are currently colliding with the player, what can we say? Well, for enemy in player collisions, I'm actually going to change the name of that. I want the S on the end. So for all enemies in the player collisions, enemy dot destroy. Destroy. Spell it right. And we're going to create a function called destroy over here in the basic enemy. So we have our update, define destroy. Destroy. I'll spell correctly one day in my life. And this is just going to call self.kill. Self.kill is actually a Pygame sprite function. So when we say self, we're calling a function within ourself or our parent, which is Pygame.sprite.sprite, and Pygame.sprite.sprite.kill just removes this thing from all groups it's currently in. And since our main method of drawing the enemy is by saying enemies.draw, when we remove it from that group, it's no longer going to get drawn, it's no longer going to get updated. The enemy technically still exists, however, it's no longer getting updated and drawn, which means it pretty much doesn't. And since it doesn't really get there, it might get garbage collected, but we can actually store it. So when we say enemy.destroy, we could also, come over here and say enemy, different group.add the enemy, and then we can actually store, the enemy elsewhere and do something with it. But we don't need it after it dies. Once it collides, it just dies. So there's no point having to deal with it. Okay, this is one collision we wanted to do. This is for the player. What's another collision we want to do? Well, this is going to be between the bullet and the enemy. That's the second collision. So I'm going to say bullet enemy. I'll just call them bullet collisions equals a pygame.sprite.groups. Collide is, I believe, the name of it. And it is just group collide. And this one, takes group 1, group 2, and then these are just kill 1, kill 2. These basically just say, are we going to remove, basically calling self.kill on the members of the group that are colliding. So what's group 1 in this occasion? Well, group 1 is going to be the bullets. So how do we access the bullet group? Well, we know it's a part of player, so player.bullets is group 1. Group 2 is enemies. So when we hit them, do we kill the bullets? I'm going to say yes, because we don't really need the bullets. And for the enemies, I'm going to say false in this occasion, because the enemy might not actually die in this particular event. So what we can say is for, again, enemy, for enemy in bullet collision, for enemy in the bullet collision, we're going to do enemy.take damage, and then of course the enemy will take damage. And again, now that we've called something like this, we just have to go and create that function. So let's see, we have a destroy, and we need to create define take damage, and this could say something like self.health minus equals 1. Maybe then check if self.health is less than or equal to 0. Self.destroy. And then we just have to create some kind of weird variable called self.health. So self.health equals, I don't know, 5? Which means they should be able to take 5 bullets now. I believe that's how this should work. The bullets die when they get hit. Enemies don't. Enemies do take damage, however. In theory, this works. In theory. Don't take my word on it. And everything went to hell. Alright, the crash issue that we had is just that this doesn't actually allow it to work. Get sprites is part of a layered sprite group. We're not using that, so it doesn't actually work. So self.bullet.sprites, I'm just going to look at the entire list of sprites and set bullet equal to it, except I'm going to say that this is just going to be the sprite at position 0, since when you call .sprites on a group, you get a list of all the sprites, and I'm just going to grab the 0. And since 0 is being assigned to bullet and we remove, we're still removing by the name reference. So maybe this will work. Run away. Oh, that one just died, so at least they collide and hit us. Can we shoot? No, we can't. Still a problem, isn't it? Instance method object has no attribute get item. Alright. Oh, get sprites. This is a function call, which means we would do the function call and then we would do the position in the list, right? That's how it works. And it still crashes. List index out of range. Well then, this obviously does not want me doing it this way. I might have to turn it back to the old list method, since this is really causing a lot of problems. Alright, I think I found out the issue. I was calling self.bullets, which is the active bullets, the ones that are moving through the scene. I was not trying to grab a bullet from the ammo. I was trying to grab a bullet from a non-existent group yet. Now that I'm grabbing from ammo, it should and does work, although we ran into another problem. So now we can shoot them. That's not the issue. What is the issue is, however, when we hit the target, attribute bullet object has no attribute, take damage. Enemy.take damage. Why is that? Because we're calling bullets before the enemies. So we just have to change the order of operations to enemies and then player bullets. Switch these to false and then true. And now this should work the way we planned it for. Don't have both of them kill me. So we can shoot. I just want to make sure that I can't overshoot. Can I shoot fast enough to clear out my inventory? Yes, I can. Okay, good. There's no errors trying to shoot an empty list. When we hit it, takes 5 to kill. Boom. And everything's working. Now my other example, of course, had these things only take 1 shot to kill, but ours take 5. That's pretty cool. Enemy.take damage. I would like to be able to pass this thing, you know, like a number, but I'm not sure how I'm going to exactly pass it a number just yet. Probably with something like, you know, player.damage, and then that would be its number that it takes. For now, I'm just going to make it take 1. So let's see. I believe that that is all of the collision I was going to do. I have a couple minutes. Maybe I can do one more thing. What would that be? Let's spawn these enemies. That sounds like fun. So the basic enemy is going to have its own spawn function. So take damage, destroy. Let's create another function. Define spawn. Spawn self. What is it going to do? Alright, so the dilemma I'm having here is I want to be able to say something like this. If self.cooldown is less than or equal to, say, 30, then what I want to be able to do is I want to be able to say enemies dot add an enemy. So, you know, add a new enemy object inside the enemy's class. This is the problem, is enemies is over in main. So I think I'm actually going to have to change some stuff up real quick. Let's see. You know, I wonder, I haven't actually tested if Python does pointer action the way I want it to. It might not. I guess we'll just have to see. So I no longer need enemies.add because of the way I'm changing this up. So I'm going to remove that. Enemies is not going to be a Pygame sprite group. Enemies is going to be a basic enemy dot enemies. Just dot enemies. What is a basic enemy dot enemy? Well, this is like a static variable. So if I come up into this zone of the class before the initializer, and I declare something called enemies, and I say it's equal to a new pygame.sprite.group, then this thing is a static to the class, meaning the individuals. So this is the individual enemy object, this is the class of enemies, and this is somewhere in between, meaning this does not get contained in each individual enemy. However, it's usable by each individual enemy. So when I initialize the enemy, I can say something right at the bottom like enemy dot enemies dot add self, and this will add this enemy object to the enemies list. And I might have called this wrong. It's not basic enemy. It is just going to be enemy.enemies. Now, what I'm talking about is pointers, is when I say enemies equals enemy.enemy, I basically just want enemies to point to this list. I don't want it to copy the list. I want it to point to it. And I believe that's how it works. And if it works that way, then all is good. So we'll have to test that. So now enemies equals just enemy.enemies. And this allows me to just keep everything the way it is with enemies, the way it's worded, without having to put an enemy in front of all of it. But it's all referencing this group here. And this group here is, of course, having stuff added to it. Enemies.add enemy. We have to actually say enemy. I know this is very stupidly confusing, but we're saying class enemy right here dot enemies, which is this variable. So we're just saying enemy dot static variable enemies, which means it's usable by every individual. And then we're going to add another object, a new enemy to it when we spawn. Self.cooldown. I need to define that somewhere. Self.cooldown equals what, 30? And self.cooldown max equals 30. And then when we spawn, if cooldown is less than or equal to 0, spawn an enemy and say self.cooldown equals self.cooldown max. And no matter what we're going to do is self.cooldown minus equals 1. So this will mean that an enemy will spawn every second. Now, where are they going to spawn? Well, we do want to change that variable, so we have to say something like new enemy equals an enemy class object. We're going to add you to the enemy. We're going to add the new enemy. And this is where we're going to set the different things. So we can say the new enemy.rect.x equals something. New enemy.rect.y equals something. But we don't know what these somethings are just yet. So what's the range of x's that it can be? Well, our enemy is 50 pixels wide. So let's go with a random. Do we have random imported? We do not. Let's import random. Import random. That way we can start using random. So random dot rand range, which I want to say, oh, here we go. So start, stop, increment. All right, so we want a start point. And we're going to say negative 100 to negative 50. So these will always spawn on the left side and, past the border on the left side. And the y will be random.rand range from negative 50, which will be like the top left corner, to the game window height, which was 600. So up to 650, just so it again can appear off the screen. And that's where we're going to randomly spawn every second. So let's test this. Run. Oh no, we're under attack. We have to shoot them to destroy them. I mean, those two enemies worked. I'm just curious as to why we don't have new ones yet. Something is definitely wrong. Random.rand range, let's see. Enemies.add the new enemy. Cooldown is less than or equal to 0. Cooldown minus equals 1. If the cooldown is good, cooldown equals cooldown.max. Oh, we're not actually calling spawn. Of course, this is always the problem with me. So self.spawn. There we go. Maybe it'll work now. Okay. Now we have our two. Oh, dear God. This is not what was intended. Oh my. This is frightening. How will we ever win? Oh wait, we're invincible. We can just charge. Assuming the game can handle this. Yeah, the game is not enjoying the super rapid spawning. I'm just going to close it. So why are we not why is this being so poor? Yeah, why isn't this piece of the function being called is my question. Anyway, I don't really have too much time to debug it, since it's just apparently being super crazy, which is completely inconsistent, but yeah, let's just eat them all. Nom nom nom. Anyway, the point of this is that you can tell that some are coming from the top and some are coming from the bottom. That is apparent. The reason why they're acting really weird is not apparent. Anyway, this video has probably gone way over time, so I thank you all for watching. This has been the 7th video of my Pie Game tutorial, and I hope to see you next time.